Hi guys, today we're going to be doing Module 3, Lesson 11. And in Module 3, Lesson 11, our learning target is that today we'll be connecting the area model to the partial product strategy and the standard algorithm. We've already been talking about the area model a little bit and have been really focused on learning the partial product strategy and the standard algorithm. So we're going to see how all three of them are related. The first thing we want to do is solve this problem. So this problem says write an equation for the area of each rectangle. Then find the sum of the two areas. And then there's an extension question which we'll address later. So first, we need to write our equation to find areas. So thinking back to when we did area and perimeter, what is the equation that we use to find the area of a rectangle? The equation that we use to find the area of a rectangle is that the area is equal to the length of our rectangle times the width. And here in our picture, we have two rectangles that have, this one has a length of 30, it tells us right here, and a width of 8. This rectangle has a length of 4, but it doesn't directly tell us what the width is. What do you think the width of this rectangle is? The width of this rectangle is 8, just like the width of this rectangle because their sides are the same. So we're going to label this rectangle A and this one B. Okay, so the area of rectangle A, we'll do that one in blue. So the area of rectangle A would be the length, which is 30, 30, times the width, which is 8. And then the area of rectangle B, which I'm going to change to green, the length is 4 and the width is the same as rectangle A, which is 8. Okay, we can look at these problems and we should easily be able to solve them because we know we can multiply, we can decompose 30 into 3 times 10 and then multiply that times 8. And then we know we can rearrange our numbers in any way we want. So we can move the 8 next to the 3 and do 3 times 8 times 10. Okay, or we can look at it as 3 tens times 8, where we would just multiply the 8 and the 3 and get 24 tens, which we should know is 240. So 3 times 8 is 24, and then we're going to have our extra 0 on the end because we're multiplying it by 10. So the area of rectangle A is 240 units because it doesn't give us a measurement. Rectangle B is much simpler, and we know 4 times 8 is 32. So the area of rectangle B is 32 square units. Now, to find the sum, the next thing it says, find the sum of the two areas. So how would we find the sum of the two areas? What does sum mean? Well, sum is the answer to an addition problem. So really, we just want to add our two rectangles together. So we would add 240 plus 32, and that's going to give us the sum of both of the areas of each rectangle. So that would give us the area of this whole rectangle if they were put together. So 240 plus 32 is 272. Okay, The extension question says, find a faster method for finding the area of the combined rectangles. So think, what would be a faster way to find this area of these two rectangles together than the way we found it? So we found rectangle A, then B, then added them together. What would be a much faster way of finding these two rectangles? A faster way for finding the area of both rectangles is also the more efficient way. So we would take and we would add together our lengths, 30 and 4, to get a total length of 34. And then we would multiply that times our width. And we should end up with the same answer. So when we're multiplying 34 times 8, the most efficient way, the fastest and simplest way to get this answer would be by doing the standard algorithm. Oops. So work through the standard algorithm with me. We're going to do 8 times 4 ones is 32 ones. And I'm going to carry my 3 right here. And then I'm going to do 8 times 3 tens is 24 tens. And then I'm going to add my 3 into the 24 and cross it out, because 24 plus 3 is 27. So here my answer is 272. And look how much faster I did that problem. Next, I want you to draw a rectangle with a length of 200 and a width of 8. Your rectangle should look like this. We are going to find the area of this rectangle. So how would you find the area of this rectangle? Well, I would multiply 200 times 8 to find the area. And I know 200 times 8 is 1,600. So going back to our previous problem, we had 2 other rectangles. One that was 30 times 8, and one that was 4 times 8. So we have the area of 3 rectangles that all have the same width. So let's combine all 3 of these rectangles together. And actually, I'm going to delineate each rectangle by changing the color. We also know the area of each one, so I'm going to record those on the inside. So earlier, our 30 by 8 rectangle was blue, which we said was 240. And then our other rectangle was green, which we said was 32. Okay, so all of these rectangles together, if we added all of them together, then we would end up with a multiplication sentence. And our multiplication problem would be just like when we did the previous one and we were finding the fastest method and we added our 30 and 4 together, our lengths together. We're going to do the same thing for this problem. So we're going to add all of the lengths together and we end up with 234 times 8. So one way we can write this problem is like this, because we know we're combining all of them, all three lengths together. So when I have a number directly outside of a parenthesis, so these things right here, these are parentheses, just as a reminder. When I have a number outside of a number inside of parentheses, that means I'm going to multiply those together. So really this is 8 times 200 plus 30 plus 4. And I can take, and looking at my area model right here, our rectangles put together, I would get the same thing if I did 8 times 200 plus 8 times 30 plus 8 times 4. So 8 times 234, which we have here, we broke down our 234 here, and we ended up with 8 times 200, 8 times 30, and 8 times 4, which is what we've really been doing when we've been looking at our partial products. Because watch this. Actually, I'm going to rewrite this problem. Eight times 200 8 times 30 and 8 times 4. And add those together. So if we added, so here again, we have 1,600, 8 times 200, 1,600. Okay, we have our 8 times 30, which is 240. And here we're showing 240. And then we have 8 times 4, which is 32. And here is 32. So when you're looking at finding the area, you are going to be looking at finding, essentially, you're just doing the partial products, but in rectangles. And then we add them up, and our answer is 1,872. Okay, let's do another problem. Okay, how many hundreds, tens, and ones are in 316? Well, there's 3 hundreds, 1 10, and 6 ones. Okay, so next we're going to draw an area model with a length of 3 hundreds, 1 10, and 6 ones, and a width of 4. Actually, my rectangle's a little long here, so shorten that up. Okay, so 3 hundreds, 1 10, 6 ones. And our length is 4. The reason why our width is 4. The reason why our width is 4 is because we're multiplying by 4. Okay, so to solve using the area model, we would multiply our 4 times 3 hundreds, which is 1,200. Then we would multiply our 4 times 110, which is 40. And we would multiply our 4 times 6 ones, which is 24. Okay, then from there, we're going to add all of those together. Okay. Okay, let's do the partial products method to show how these two are related. Well, I'm going to start with 4 times 6 ones, which is 24. 4 times 110, which is 40, and 4 times 3 hundredths, which is 1,200. Okay, do you see how my numbers came directly from this area model? We have the same pieces to add together to find our answer. Okay, let's try the standard algorithm to show this multiplication problem. Okay, so 4 times 6 is 24. I'm going to carry that 2 on the line. 4 times 1 is 4 plus our 2, which is 6. And then 4 times 3 is 12. So we have the same answer multiple times. Here's the answer for our area model. Here's the answer for our partial products. And here's the answer for our standard algorithm. They are all three the same. So when you're doing your practice work today, I really want you to think about using the area model and how you're going to represent your area model. If you need help, you need to rewatch the video and see how we represented our area model. Remember, we're going to break up our number into hundreds, tens, and ones, maybe even thousands if your number has 1,000 in it. And then multiply each of those by the width, which would be the single digit number you're multiplying by.